right, we're going to start where we were last week. I'll try and get this brightened up best I can. We were working on wrapping up the review, and we're going to move on to a new section. Now at this point, I think I mentioned that I'm through with the review, right? And so we're done with page 643, number 32. So all this stuff about area and perimeter, we're moving on, right? So now we're going to do so now we're going to talk about the types of geometric shapes. So we're going to be talking about spatial reasoning and all that. Cylinders, prisms, spheres, all that sorts of stuff, okay? And we're going to be, we're learning about that sort of thing. So we're going to talk about, it's called the solid geometry, okay? So I'm going to pull this over and let you look at this page for just a minute. This is on chapter 10, section 1. And I'm going to pull that back so you can kind of understand what's going on here. All right, so just a kind of a brief overview of what we're going to be doing. This next couple of weeks, we're going to hit, we're going to do chapter 10. We're going to hit the review and see how much of that we'll actually be covering. So I think as far as this chapter is concerned, we're probably going to cover most of it, except for we might cut off a thing or two here. Yeah, we're going to need all this, I think. We're talking about spheres and volumes of pyramids and cones, surface area of pyramids and cones, volumes of prisms and cylinders. Now, I am going to mention to you that out of these sections that I'm looking at, the most difficult ones are going to be the ones dealing with surface area, because there's going to be a lot of information that you're going to have to keep up with. Formulas for three-dimensional objects, we'll talk about that. We'll start that off, and we may even get into the views of a geometric shape. And I taught this when I taught an engineering class a couple of years back, and it was pretty interesting. But so in other words, you're going to see this material not only in this class, but you're going to see this probably the rest of your life. Just because some of you may be going into engineering, some of you may be going into interior design or something like that, and you're going to need to know what these objects are and what the views are. What does it mean when I say the front view or the top view of a prism? What does that look like? So, all right, so this is pretty interesting. I've seen this happen before, where they take a form and they grow a watermelon inside of a square-shaped wooden form, and then the watermelon forms itself to that to fill the volume of that. So this is where this is applicable, but that's pretty cool, I think, how you can make a watermelon change shape based off what it's growing inside of. All right, so now we're just basically today is going to be, I'm going to definitely take notes, obviously, like I always do, but it's going to be a little slower at first, because you need to know what these things are, right? And you're going to think, oh, well, I know what a cylinder is. Well, go try and find the surface area of a cylinder and see what happens, because it's going to be pretty advanced, especially when you get into the other formulas, like the surface area of a cone and things like that. I mean, come on now. You got to take this slow at first, and then we'll get to the hard stuff later, okay? All right, so we've got, so Mr. King is my name, and I'm going to put it at the top of my paper, and today's date is 5/11. Okay, and so the title of this is going to be Chapter 10.1, Solid Geometry. Just all you have to do is just take notes like I'm doing, and we're good, okay? I'm not going to stress or worry about any kind of homework or stuff like I would normally worry about, because we're not in that format at this point. Okay, so I'm going to try and take notes as good as I can and explain things as well as I can. All right, so we're going to go through, and it says three-dimensional figures or solids can be made up of flat or curved surfaces. Each flat surface is called a face. So we have a face, 6 faces on this, just like you would have faces on a dice. And let's move on. It says an edge is the segment that is the intersection of the two faces. So if you notice that there's a little red point, I don't know if you can see this really closely. All right, so on this shape here, there's a little red dot here that's called the vertex. That's not what I'm talking about when I say edge. If you can touch it and it hurts to touch it, like if it's sharp right there, that's a vertices, okay? That's a vertex. If there's an edge, in woodworking, most of the time, what people would do is they would sand the edges to keep things from being so sharp. Sharp edges that have been cut with a bandsaw, they would round those over with sandpaper. And so this edge right here is the line on the side. The vertex is where it comes to a sharp point. So if you're dealing with like children's toys, you would want to make sure that all these edges and sharp points are sanded down, rounded down into curves. And so a vertex is the point at the intersection of 3 or more faces. Okay, so I'm not going to worry about defining those right now. I'm just going with what I have here. Now we're going to start talking about what a prism is. You need to know what a prism is, so let's write that out. And you need to know what a cylinder is. Now we're going to break this into 4 sections: pyramid, and then cone. All right, so down each section here, I'm going to put, let me back this up so you can see what I'm doing here. So down each section, I'm going to put the information for a prism, the information for a cylinder, pyramid, and cone in that format. And then we'll draw lines where we have to stop here. So first I'm going to define it, what a prism is. A prism is formed by 2 parallel congruent now hold on. Polygonal faces called bases connected by faces that are parallelograms. So there's a lot going on here. So I'm going to write that out here. I'm just going to I'm going to write down what I see right here underneath prism. Okay. So a prism is formed by 2 parallel congruent polygonal faces called bases. I'm going to underline that. Connected by faces. Bases connected by faces that are parallelograms. That are parallelograms. All right, so we're going to put the definitions here. So I'm going to put definitions. So this is going to be kind of like, okay, I want to show you what's going on here. So I'm going to break this down. We've got a prism definition here. We're going to have a cylinder definition here, pyramid definition here, and then cone definition is going to be off to the side. So this is where, and I don't know how long these definitions are, but we'll draw off the line when we get through here. So let's talk about what a cylinder is. I'm going to write this down. I'm reading right here. A cylinder is formed by 2 parallel congruent circular bases, underline that again, and a curved surface that connects the bases. All right. So now there's your drawing there. We got a cylinder. Let's there, clear that up. Okay, so there's our, so both of these, let's go back and hit this real quick. It says formed by two parallel congruent. Then this side has, this one has polygonal faces. This one has circular bases. All right, polygonal bases and circular bases. Look at this. So in this case, a prism can have some kind of polygon for the top and the bottom, but they have to be congruent. They have to be equal and parallel. In this case, this is different. This is not a polygon. This is a circle. So you have to call this a different type of an idea. So it's here, circular bases. Now, then, and they're connected by faces that are parallelograms. And then this right here says this has a curved surface that connects the base. So it's just like a label on a can of beans. It's curved or wrapped around. There's no sharp edges for the sides. It's wrapped around. So that's important that you remember that. So pyramid is, let's write that definition down right here. So we're here. Pyramid is formed by a polygonal base and a triangular face that mates at a common vertex. So formed by a polygonal base, just like the prism is. So it starts off like a prism. And triangular, this is what's different. It has to be triangular faces that meet at a common vertex. Now remember what I said about vertexes. The vertex is that sharp point right there at the tip. If you touched it, it would actually hurt to touch it because it's just a sharp point, okay? That's not the same as an edge. An edge is the side where these faces meet, okay? It's not the corner, it's the side. So there's a difference between the vertex and the edge. This has one vertex. Actually, it has three vertices. 1, 2, 3, actually 4 vertices. 1, 2, 3, 4 sharp points. And it has, how many edges does this have? 1, I'm looking at the line. 2 line, 3 line, 4 line, 5 line, 6 line. So it has 4 sharp points and 6 edges. That should help you decipher the difference there. Okay, so now let's talk about a cone. A cone is formed by a circular base. All right, let's write that here. Formed by a circular base. So we have a circle at the bottom and a curved surface that connects the base to the vertex. And a curved surface that connects the base to a vertex. Okay, so now at this point, I'm going to draw a line here because the definitions are done for all 4 of these items. We know what they look like. We did not draw them. Let's go ahead and try and draw them. Let's do a drawing of each one now, okay, using the definition. So I'm going to back this up so you can see what my notes look like so far. So we're going to do a drawing now of each one of these. A prism could be any shape. Now I'm going to draw a different shape than what they had. I'm going to draw a pentagon, kind of a oblong pentagon, looks like this. All right, remember that this shape has to be parallel and congruent to its base. So let's draw another pentagon, kind of straight underneath. Now I'm just freehanding this, so it's going to be not right, but it's going to be close-ish. Okay. So we're drawing 2 pentagons, one hovering above each other, kind of like a UFO or something. So I'm going to come on down and draw a straight line down, 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 down. Now what I just did is I drew the edges. All right, I'm going to draw another edge in the back that you can't see. Now I should have, if I were drawing this correctly, I should have dotted this side and this side, but hey, we're going to go with it just like it is. And so we're going to shade lightly the top and the bottom. All right. Those are called the bases. So I'm going to write bases here and here. And I'm going to write edges here. And then I'm going to put a big old Rudolph nose dot right there and call that the vertex. All right, just like that. Now we're going to draw this straight down. So there's my prism. It's parallel congruent polygonal faces called bases connected by faces that are parallelograms. So the faces here, we need to make sure we understand what the face is. Let's see if I can distinguish that. Maybe like that. Okay, so let's call that the face. So this is a face on that side there. If you'll notice, it's a parallelogram itself. It's a rectangle. All right. So now this is called, and like it's an either an orthogonal view or isometric view, the way you want to look at it. Depends on which angle you're talking about, but this is a type of view of a three-dimensional object that we just drew. So I'm teaching you how to draw views. Those of you who want to be an engineer, this is going to be extremely important that you understand how to explain this, because you want other people that know how to do this also to know that you know what you're talking about. All right. So it's very important that this is take this to heart if you're interested in making this a profession. All right. So cylinder, let's draw kind of like an oval shape, looks like that. So this is kind of a circle looked at from a weird angle there. I'm going to come down here and draw the same egg shape again. Kind of try to make it about the same size, because they have to be congruent circular bases. And then now I'm going to draw what would be considered the edge, but there are no edges on a circle. So there's this is just one solid circular curved surface. All right, so right here we've got two bases. We've got a curved surface here, okay? So that's how you draw a cylinder. Let's talk about a pyramid. Pyramid, look, it starts off, it says it's formed by a polygonal base. Let's do another pentagon again. Let's do it. I'm in pentagon mode today. All right, so let's do a pentagon, five-sided shape. And we're going to come to a vertex right here. It's a sharp point, and we're going to draw an edge from vertex to vertex. Here's another vertex. I'm going to draw to that vertex. There's another vertex. I'm going to draw to that vertex. And now I've got these are supposed to be straight lines. And now I've got one in the back that you can't see, so I'm going to draw that dotted there. I'm going to shade this in. This is a base, okay? And then the faces are triangular faces, okay? So I want to draw this right here. This face is triangular. All right? And up here is the vertex, and down there is the base. All right, so now let's go to the next one. So you've done three kind of orthogonal views here. You've done a prism, a cylinder, and a pyramid. All right, in this case here, we're going to talk about a cone. A cone is exactly like a pyramid, except it's a circular base. I'm going to draw an egg shape again. I'm going to draw a vertex, and then from that vertex, it says it connects to the base. So we're going to draw like from here to here. All right, so that's your cone. It's got a circular base, and the sides are curved surface. Okay, so that's how that works. Now let's go on down. We've got those four things dealt with. Draw another line. Okay, lot of note taking today. So let's go down to the next part and talk about prisms, cylinders, pyramids, and cones, and hit the high points here. All right, now I'm just going to touch this once and then we'll go on. It says a cube is a prism with 6 square faces. So that's just a special type of thing. So if you hear me talk about a cube, it's basically going to be a dice. All right, so let's talk about this. How do we know what type of prism we've got, all right, and what type of pyramid we've got? Remember how a minute ago we had a pentagon for the base here? Well, you're going to call this a pentagonal prism, right? So I want you to write this word out. Pentagonal, it's pentagon with an AL at the end, prism, all right? And this right here is a pentagonal pyramid. There's a difference. The pyramid comes to a point, okay? Pyramid comes to a sharp point here, and the prism does not. It has 2 of the same shape. So in other words, it doesn't come to, if it comes to a sharp point, bop, 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 those are called pyramids. And that's why they, and this one's a hexagonal because it's got 6 sides for the base. All right, this is a hexagonal prism because it's got a hexagon at the bottom and a hexagon at the top and connected the edges there. All right, now that helps kind of set the floor for what we're doing next. All right, so we're going to classify some 3-dimensional figures, and I'm not going to draw anything or write anything for right now. I just want you to see this. All right. So let's go over this example 1. We're probably going to go back and rewrite this. We usually write the example, the 2 examples down, so we'll do those on our notes. But we're going to hit the high points here and talk about these. What is this? This is a cylinder because it's got a circle, 2 circle bases that are congruent, the P and the Q circle, and then the sides of it are curved surfaces. There's no flat edge like there is on this. All right, this is a prism, a pyramid because it comes to a point, okay? So you could call it a square or rectangular pyramid, depending on however the dimensions of this down here. If they're all the same, then it's a square pyramid. If it's just a quadrilateral with right angles, it's going to have be called rectangular. So, all right, so let's talk about the vertices. There's going to be A, B, C, D, E. In other words, if you touch this, there's going to be 5 places on this shape that hurt. 1, 2, 3, 4, 5 points that hurt if you touch it. Okay, so if you'll notice right here, edges are the long lines connecting the vertices. So we have let's get our pin down here. So we've got AB, BC, CD, AD. And then we also have CE, DE, AE, and BE. Those are the edges. Now the base is a rectangle ABCD, just like that. The bases here are circle P and circle Q. There's no vertices, there's no sharp points on here, okay? But then there's no edges. So we're gonna actually draw this out. I want you to get practice writing these notes. So we're gonna draw this exactly like it looks. I'm gonna pull this out of the way. Now we're gonna draw this underneath. So right here is going to be, this is where your pyramid is. So we're going to draw here and here, underneath here and here. So let's go redraw this rectangular pyramid here. I'm going to draw a slanted, kind of like a rhombus. It's a slanted quadrilateral, comes to a point, and we have lines drawn for all vertices to connect. And then I'm going to call this A, B. So now I'm notice that I'm writing this, I'm drawing this differently than the book. So just, it's okay. And then, so now we're going to call this, I'm going to draw an arrow right here. This one's called a rectangular prism. Or pyramid. I keep getting that mixed up in my mind. Pyramid. mid. Okay, and so now the vertices are A, B, C, D, E. And the edges are AB, line segment, BC, line segment, CD, and then DA, because it comes back around. And then we have EDA, EA, everything with an E. EA, EB, EC, and ED. Okay, just like that. Now the last part says the base. We're going to talk about what the base looks like. The base is a rectangle. Okay, so then we put that just like that, so our notes look like this. And so now I'm going to draw a line down. Now obviously I can't really draw a line like that. I'm just trying to keep this all straight. Okay, so this is all dealing with pyramids right here, and then we're going to do a cylinder right here. So let's draw another cylinder. Little circle, little circle. Try to do the same thing for both circles to make them congruent. So we're just drawing a little circle, another circle, so about the same width, diameter. Okay, and so down here, we're going to call this circle P. This is circle Q. All right, this is called a cylinder. Now it's vertices, none. Double underline that. Edges, none. Double underline that. Okay, so now we're going to come down just like that. Trying to keep these notes a little bit organized if we can. Now we're going to look at example. Oh, just as a little high point here, let's see if we can understand what these are. What is this called? All right, so we've got a circle and it comes to a vertex point. So it must look like a circular pyramid, right? Nope, it's called a cone, right? So that's the name of it. It's obvious. Everybody understands that that's an ice cream cone. It could be called a circular pyramid, but you know, there are no edges, there are no vertices, so you have to give it a name. Let's look at this. This is triangular for its base here, and the bottom down here would also be another triangle, like a big piece of cheese. So the sides are polygonal, or polygonal, I don't know how you'd say that. Sides connecting the vertices. So these edges here form a polygon. So this is a prism, but what kind of prism? If you'll notice, the bases are triangular, so it's a triangular prism. All right, now let's go down here. Now we're going to talk about what a net looks like. Now, it says a net is a diagram of the surfaces of three-dimensional figures that can be folded to form a three-dimensional figure. Now, I've got an object I'll show you tomorrow. I'll do a little video of it and show you what a net looks like in the real world. People use them every day. And it'd be pretty obvious when I show you. There's nothing to it. But we're talking about measuring the surface area of things. And so we're going to be dealing with the nets first. We're going to figure out what the areas look like, what those shapes are. Triangular prisms, you know, in this situation. This would be a square pyramid, because if you fold this together, all four of these sides fold up to form a sharp point. You see that point there? Those points would all touch, and it would make a pyramid when you fold it together. So this is triangular prism and a square pyramid. All right, so we're going to describe the three-dimensional figures that can be made from the given net. And now I'm going to draw the net first. And so let's go over here, and now let's keep our prisms with prisms and our pyramids with pyramids, okay? So I'm going to draw this net under the prism format, and then I'm going to draw this under the pyramid. So I'm going to basically redraw this the best way I can. So I'm going to keep it side by side. I'm going to draw a net. So this is called a net. All right, and so I'm going to draw a rectangle here in the middle, and then I'm going to draw kind of a slanted let's do it. Let's go all the way down and make it nice and neat there. So there's my triangular prism. Okay. Now, let's look at this. This is called a net. So I'm going to keep that here. This is these are not a net here. So let's all right. So these are not a net over here. So that's going to be confusing a little bit. But this is a net here. So now let's write out. It says has two congruent triangular faces, right? And then I'm going to shade those in. Those would be what I would consider the base. Okay. The remaining faces are parallelograms. Okay, so this net forms a triangular prism. I'm going to box that and then draw that line down. So we're pretty much wrapping up the notes here, okay? So our notes, what do they look like so far? They look like this, okay? And we're going to fill in the spaces down here. I'm going to draw the net for the pyramid down here. I'm going to try and keep these spaces open in case we have anything else dealing with cones or cylinders, okay? We haven't gotten to that point yet. So we're going to draw a net for this, okay? And so we're going to draw this net right here. So basically we're going to draw a big square. It looks like this, and I'm going to come out about this distance, about this same distance all the way across. So it's this same distance about up to there. Let's see. I may not get this quite right. You know what you could do is to make everything nice and pretty, you could take another sheet of paper like this, and let's zoom in on what I'm doing here. So I'm on this net, and I'm saying that if I want everything to be the same distance, I can take another sheet of paper and just look at that and make little marks. If you don't have a ruler on you, this is just an easy way to do that. So that's about the right distance there, and then this should be about the right distance here. So let's put a dot right there. Now these are not I mean, I'm going to try and draw it the best I can, but it's not going to be exact. As close as it can be. All right, and each one of these sides here, these faces, are triangular. And remember, that's part of being a pyramid. Your faces have to be triangular. Over here, your faces are not triangular. Your bases are triangular, but your faces aren't. All right. The base here is a square. So I'm going to highlight that base with my pen here. So this is called a square pyramid. All right. Now, the net has one square face, and the remaining faces are triangles. So I'm just going to put as a side note, square base. And last note here at the very bottom, triangular faces. All right, so those are the two distinguishing factors for a square pyramid. I'm going to box that just like I did up here to be as uniform as possible. Okay, so we're good. Now let's go to the next example. So if you need to, you can pause the video right here and write what I have and then send that in to me. look at all the stuff that you've drawn today. Okay, so that's a lot of information. If you followed me, that's pretty good. This would be a triangular. We're just classifying nets now. Okay, that's what we're doing here. This would be a triangular base with triangular faces. So this would be a triangular pyramid. This is two congruent bases. So it's the circles are two congruent circles. And then it has this one rectangular, think of it like the label on a can of beans. So if you folded that in and then wrapped that label around, it would be a curved surface, right? So that's how you would get a cylinder. There's your can. Here's your can without the label on it, all right? So if you pull the label off, it would look like a rectangle. Everybody's done that. All right, look at your little squished watermelon here. You see that? So that you can do all sorts of different shapes, I'm sure, with the watermelon. This is just a little square prism that they've done here. They just made a cube. That's a cube shaped watermelon. All right, so let's go to example 3. I don't know how much time we've got left, but we're going to talk about what a cross section is. You know, it's important that you understand what a cross section is, especially those of you who are thinking about becoming engineers, or doing any sort of drawing, graphic design, things in the future. If you play Fruit Ninja, you slice it or fruit. Well, that's called a cross section, right? So a cross section is the intersection of three-dimensional figure with a plane. So in other words, think of a line going right through the middle. What would happen? And what would happen is it would slice this little part right here into, you see that circle in the middle? That's called a cross section. You see this little triangular part here? That's called a cross section. Here, your cross section would be hexagonal. It's got 6 sides. Here your cross section would be triangular. I know that doesn't look right, but it is. The cross section would be a triangle. See that on this cone? And then, so I'm not gonna, well, I think, okay. So I'm not gonna make you draw that. I just wanted you to see that. So I'm gonna leave example 3 alone. I just wanted you to know what a cross section was. And then let's move down. I'm not going to hit this too much, but we're going to talk about square and a hexagon. If you were to slice this watermelon right through with a knife or a big blade, you would see that the inside of it would make kind of a square shape. And if you go like at a slant, like that, you would have almost a hexagonal shape. I know it sounds funny, but it depends. Okay, if you were to start from right here and slice down through to the bottom, like if you went from above and went check like that in a slant, that's what would happen. You would have a hexagonal. It's called a cross section. All right, so now let's go through. I think we're going to wrap up today just talking about. I don't know if I can make it cut off like I usually do, but I'm going to just talk about these real fast. So a blank has 2 circular bases. It's not a prism. It's not a cone. It's a cylinder, right? A cylinder has 2 circular bases. We're going to classify each figure and name the vertices of each base. So we've got a cone here. It's a circle with a vertex. We have a rectangular prism here, because these are 2 congruent rectangles. The faces are polygonal. And then the bottom down here is a triangle. So it's triangular. It comes to a point. So it's a pyramid. All right, these nets this would be a cone shape. So you have a circle base. And if you were to take, like a ice cream cone or a snow cone, if you were to take the wrapper and stretch it out, it would look like this. Okay. So that's called a cone net. This is a rectangular prism. So the 2 things that are congruent are the bases here are rectangles. So it's called a rectangular. Now, if you notice, all the sides are polygonal faces. So this is called a prism. It doesn't come to a point.